So this is question 11 of the mix exercise. Part A says find an equation of the line AB. Absolutely standard. So there is zero thinking almost in this question. Okay, we just substituting in numbers. R is equal to A plus TB, where T is a scalar, B is the direction vector, and A is a point on the line. So we are simply using this. Direction. Point on the line. Scalar. Scalar parameter. Okay, so let's choose now. Let's follow it in order. Okay, so what's our A? There's our A. That's the point A and B. So we'll take the first point, that'll be our A. Could have chosen B, but normally in the mark schemes, they just take the first point A that's given as their A, so we'll do that. So find an equation of the line AB. So R is the vector equation, is 5 on the right, this is a column vector, -1, -1, plus T or lambda or mu, let's call it T, okay? Direction vector, well that is given by, well let us now look at the vector AB. What is the vector AB? That's B minus A. So the vector AB will be our direction vector. So that's going to be 5. So let me just, it'll be this vector minus this vector. So 1 minus 5 is -4. -5 minus -1 is -4 again. 7 minus -1 is 8. Now, that, let me just break this down for you. They're all multiples of 4. So if I take out 4, I have -1 -1, 2. And because now this vector is a multiple, so this vector is a multiple of that vector, we can actually use, sometimes you may see the answer in the back of the book is slightly different. You might not see -4, -4, 8. You might see -1 -1, 2. But that's in the same direction because one is a multiple of the other. Okay, so very important point that if I would have used -4 -4, 8, it's still correct. But I can factor out 4 and realize that -1 -1, 2 is in the same direction. So I could use that as my direction vector. Just make sure that's the same color in its simplest form. Okay, so that is our equation for part A. Now part B says show that the point C with position vector 4i minus 2j plus k lies on AB. Exactly the same as question 10 almost. So please see my video tutorial on question 10 if you haven't already done so. Okay, so from part A, here's our equation of the line. And again, if I look at the I component, we take the I component, we can say that 5 minus t, so I'm just taking it from the I component, 5 minus t has to equal to 4. And therefore, t has to equal to 1. And when t is equal to 1, when t equals to 1, r is equal to, if I substitute t is equal to 1 into here, I get 4 minus 2, 1. And therefore C lies on A, B. Okay, simply substituting t equals to 1 into this vector equation, I get the point 4 minus 2, 1, and therefore C lies on AB. So for part C, it says that OC is perpendicular to AB. For the vector OC, let me just make an important point here. The position vector of C is the vector OC. Let me repeat that. Two different ways of saying exactly the same thing. The vector OC is the position vector of C, because the position vector is always referred to the origin O. So the vector OC is the position vector, which is equal to 4 minus 2, 1. We have the direction vector of AB, and we know, I'm going to put this in red, that when two lines are perpendicular, then the dot product is equal to 0. Fundamental. So if I now compute the dot product, okay, so I'm going to do OC dot AB, OC dot AB, that is equal to 4 minus 2, 1 dot minus 1 minus 1, 2. And let's see what we get. We get minus 4 plus 2 equals to 0. And therefore, OC is perpendicular to AB. So, for question D, find the position vector of the point D, where D does not equal to A on AB, such that OD is equal to OA. So, it lies on the line. Such that the point O to D is equal to O to A. So we can say that that distance is equal to that distance. So let's work out the point OA. The distance OA is equal to the square root of 5 squared plus minus 1 squared plus minus 1 squared. That is equal to the square root of 27, which is equal to 3 root 3. I want to highlight the key word here. The key word here is on AB. If D lies on AB, then D lies on this line. Any point on that line will be of this form. R is equal to, I'm just going to remove the bracket. it will be 5 minus t for the I component, minus 1 minus t, and minus 1 plus 2t. Any point will have that position vector. This technique is very common. If it lies on the line, it will have position vector. So I'm going to suppose now I have to find the value of b. Well, I know that OD, the distance OD is equal to the distance OA. So another little technique is to say that therefore OD squared is equal to OA squared. Okay, so that is an important line there. We're going to use this fact. So OA squared is 27, okay? So OD squared, I can say, is equal to 5 minus t all squared plus minus 1 minus t all squared plus minus 1 plus 2t all squared, and that has to equal to 27. And that looks like a simple quadratic equation to solve. Okay, so let's just quickly expand this. And if I remove the brackets, and you can check this calculation at home, you get 5 6t squared. And when we expand and simplify, we should get this. If I subtract 27 from both sides, divide by 6, I get t squared minus 2t is equal to 0. And therefore, t is equal to 0, which gives us a, or t is equal to 2. And when I substitute t is equal to 2, I get the position vector of b. If I substitute t is equal to 2 into here, my position vector of b, and you'll find that when I do substitute into there, r is equal to 3 minus 3, 3. And therefore, the position vector of b is, if you want to put it in IJK notation, is 3i minus 3j plus 3k. And that is our final answer.